Good morning. Welcome to the second day of SciPy tutorials. I'll be your host. My name is Ryan May. I'm a software developer at Unidata. The focus today is on learning how to set up your own open source project. I'll let my colleague introduce himself.
So I'm John Leeman. I'm also a software developer at Unidata. I'm a geophysicist by background, a little bit different than Ryan, who's got a meteorological background. A couple of notes on the way we're going to run things today. Unlike some sessions where we're going through Jupyter notebooks and that sort of thing, you will not see a single Jupyter notebook today. This is highly interactive, which means we can all fail together when we're trying to get some of these things to work. So there's going to be a lot of sections where you're going to need to help, write some tests or set up an online service against a repository. So make sure that if you're having trouble, you flag us down and we'll get you the help that you need. We've got stickies. Are people familiar with the software carpentry sticky method? Okay, so the green, in quotes, this is the closest thing we could find to target. Blue sticky, when we're doing exercises and things, if everything's going great or you're done with the exercise, you put this up on the back of your laptop. Our stand-in for red, which is this orange, is you're stuck, you need help, something's wrong, put this on your laptop, one of us will see it, and we'll come by and help you. These are not colorblind safe, unfortunately, so if you're having some trouble with it, ask us and we can annotate on here for you. There's also a Slack channel. It's open source project in the SciPy 2018 Slack. Whichever one of us is not teaching will be in there. I've also got the links that are on the board posted in there if you don't want to have to type them in. So you can go ahead and join that. I saw several people already have. And then, again, we'll be running things mostly off this website, which I will let Ryan introduce. But a brief outline of some of the stuff that we're going to hit today. First, we're going to make sure everybody is set up. We're going to get a Git repo for your project set up. The project we're going to be working with today is called HUGS, which is the hugely useful geoscience stuff to play on Matt Hall's Bruges, which is a bag of really useful geophysical equations and stuff. Then we're going to talk about testing and setting testing up using TravisCI, Flake 8, building docs with Sphinx, and getting them online with ReadTheDocs, as well as testing the docs with Travis.
So just to start, as a show of hands, how many of you have Git installed on your computer? Okay, excellent. And then, what else did I need? How many of you already did the install and set up your environment with Conda? Okay, we are in good shape here. So while John's doing that, I'm going to go ahead and start my install, just to be thorough here. And let that go. So has anyone out there never used GitHub before? Okay, so we have the basics of that installed. So we're going to use GitHub to host this project. We're just creating a hypothetical project here. We're not hypothetical. We're just creating a toy project here, John's Hugs, and we'll set that up and we'll go through the steps of selecting all these things. So while that environment finishes creating, the first step in setting up any open source project is, what's your license going to be? So what are some of the licenses, software licenses you guys have heard of or are familiar with? Just throw some out there. Okay, MIT, Apache, BSD, GPL. I mean, we don't make an exhaustive list. Anyone else want to throw out their favorite? Government, yes. So the important part of any one of these is that they dictate the terms under which anyone can use the code that you've posted online. You may think that just throwing it up on GitHub is enough to open source it, but without a license file in your repository, legally speaking, you maintain all rights to the code. Just because you put it up there doesn't mean people can use it at will. So it's very important to actually go through the process of putting a license on there so that other people can be sure that, yes, they have permission. You're not going to come back and sue them later for using your code or whatnot. And so it is important to choose a license. I know a lot of people think, oh, I don't care, I just don't want to deal with this, I'm not putting anything up. But if you don't have a license, no one should be touching your code, technically speaking. So I'm going to come over here. The first thing we want to do is let's create a repository on GitHub. So if you go to github.com and you're logged in, this is what you should see. Or something like it, depending on what your account looks like. And step one here is we want to click this big green button here that says New Repository. And we'll blow this up a little bit. There we go. So, create a new repository. I'm going to leave myself as the owner. You put yourself as the owner. For purposes of this, because we're going to be putting some documentation up on ReadTheDocs, we need to have unique names for these projects. And so I'm going to call mine Hugs-Doppler Shift. You can call it really, the name is not important, so if you want to call it something else, by all means just pick a name, but if two of you have the same name, when we go to put things on ReadTheDocs, they'll collide, and I'm not sure what will happen actually. So choose my repository name, edit a description. I'm just going to type something here. Okay, make this public. I'll go ahead and initialize this with a readme, so that's a nice feature on GitHub. If you've not seen, that's where you can get all that text by default that comes up when someone visits your repository page. So it's a nice thing to have. You can put other useful links to your documentation. You can put all sorts of these little icons called badges that point to other online services, things about the project, links to where you can find, for instance, the PyPI package. Since we're doing a Python project, I'll go down here and select Python for my git ignore. There's a large number of languages supported here. And then the license. So besides selecting license, we didn't actually cover the two main types of licenses. So they largely fall into two categories. One of those licenses are what's called copyleft licenses. That would be something like the GPL, the LGPL. What those say is, in the case of the GPL, any code that derives, for a project, any code that derives from this code must also fulfill the terms of this license. So essentially, that means if I'm using a GPL library, my code must also be GPL'd. That's what it comes down to. And because of that nature of anything that derives from it must maintain that same license, they kind of call it a viral license because it just kind of perpetuates through this chain of dependencies. Some people really like that aspect of it, and some people aren't so hot about it. The other class of license are what's called permissive licenses. That would be the MIT, BSD, Apache, those ones. And essentially what those say, with some variation, is do what you want with this code. I'm not responsible for it, and just make sure you keep the license with the files and make it clear to people that yes, I'm basing this on some open source code. So that's more or less what the permissive license are doing, is it's allowing pretty much anyone to do whatever they want with it as long as they maintain a license. So those are your two big classes. Usually in the scientific Python community, the standard is to use one of the more permissive licenses. The one I see most often would be the BSD, I think 3-clause license. So that's what we'll select down here is, I'll go ahead and use the BSD3. You see GitHub already promotes a few of the ones here, Apache, GNU, GPL, MIT. For consistency, I'm going to choose BSD3. Really, this is a toy repo, so feel free to choose whatever you want, but first thing first, we choose a license out of this selector. I have this here because I have an app installed on my account. We'll get to that in a second, so don't worry about that. So we got our options selected for our new repository. We can go ahead and click Create. Let that chug, and here we go. Voila. My own home for my new open source project. I've already got the readme file populated where I could put content in there. I've got my getignore file, which if we click in there, we see a whole bunch of Python-y things being ignored. All sorts of things for packaging, Spider project files, virtual environment files, all sorts of things. Anything you could possibly not want checked in is in here, it looks like. Okay, that's good. So if I go back, the other thing I want to look at is, okay, there's my license file. If I look in there, GitHub, for all the license files on GitHub, if it understands it, it's able to give you more of a rundown of the features of the license, which is nice for your users. And then here we see, here's the standard text of the BSD 3-clause license. I chose Python. It's not going to be critical for this, so if you didn't choose it and already created it, it's fine. We can also update the file later if we need to, but not going to be critical for what we're doing this morning. All right, so there's our license. Getignore, readme. All right, we're already set up and ready to rock and roll now. So, last step here, now that we've created something online, is we need to get that locally. So let's go ahead and bring that down to our computers. So I'm going to go over to my terminal here. Where am I? I'm in here. So go to wherever. How many of you are going to be using the GitHub GUI, like the GitHub desktop app? Just curious. All command line or whichever you prefer. We just need to get the repository down locally. So I'm going to be doing things on the command line. Git clone. You don't have to follow along with that if you don't want to. But the important part is we want to go over here and get this repository downloaded. So I'm actually going to take the shortcut here. If you click this green button here on your repository that says clone or download, we can go over here and just click this, and it'll copy the URL to your clipboard. If I come over back to my terminal, I can say git clone and paste that in. And so don't clone mine. You should be going through and making your own, cloning your own locally. So as a first run through here, can you, when you've got your repository cloned locally, can you put up your green sticky? Okay.
Okay, so see lots of green stickies, so go ahead and take those down. Thanks for using them. So the next thing that we're going to talk about is testing in your repository. So we're going to set up the sample project. We're going to copy some canned library code into the repository that you just made and talk a little bit about the types of tests and then actually write a few tests. So this will be a pretty hands-on session. To save time so we don't have to write some library code ourselves, we're going to copy in some library code from this github.com/jrleeman/setting up open source URL here on the board. So if you want to, you could clone this, or since we're not really going to do any Git magic with this, you could download the zip. Either way is fine. So you can download zip here. So it's github.com/jrleeman/setting up open source. And it is in the Slack, yes. So then go ahead and unzip that file or open up the folder that you downloaded here. So I'm going to go to Downloads. There we go. It's always fun using someone else's machine that has slightly different shortcut set up. So I've got this setting up open source master. I'm going to go ahead and open that. And we're going to need this hugs directory, which has our sample code, and the setup.py file. So copy those into your repository that you created, in whichever way is most convenient for you. You can do it from the command line, or you could just drag across either one. The whole folder, so the whole hugs folder and the setup.py file. But you don't need the environment or readme or license. You'll already have the get ignore and license and so on. So everybody good there? Are we having any problems copying those things across? Okay. So the next thing that we're going to do then is activate our environment that we created earlier on. So in this case, it's going to be conda activate if you're on a newer version, or source activate if you're on an older version, or just activate if you're on Windows, of our environment name. So source activate in our terminal here, SUOS for setting up open source to activate our environment. And make sure that you are in the directory of your repository on your terminal. So if you do a pwd, you should be in hugs dash your last name or whatever you called your repository. What was that? It's source activate SUOS. Or conda activate if you're on the most recent version, right? Okay, so once you're CD'd into the appropriate directory here, we need to go ahead and install into our environment the hugs library, but we need to make an editable install because we're going to be doing changes and we want that to propagate. So to do that, run the command pip install. And with flag E for editable. And then a period because our setup.py file is in the directory that we're in currently. So at the end you should see successfully installed hugs, which is a very nice little message. So if you got that, put your green sticky up. If you're having a problem, red sticky. Okay, so it looks like everybody's got the pip install command to work. See lots of green stickies. So the next thing that we're going to do is go ahead and commit this code that we've copied in to the repository. How many folks are very familiar with Git, you would say? Okay, so decent amount. The first command that we're going to want to run here is a git status. Make this a little bit wider so the text wrapping's not so bad there. Okay, so what you should see here is Git's telling us that there are untracked files. There's a hugs directory that in turn has a lot of content in it, and this setup.py file that it doesn't know anything about. So we want to go ahead and track those files. We're going to add them to version tracking using the git add command. Git add, and then in this case we can use flag capital A to add all untracked files. This is not necessarily the most common command that you'll use, but when we're first getting set up, it's pretty handy. So now if we do a git status, you see that we have all of these new files that are ready to be committed. They're staged. So is anybody having any problems getting to there? So again, that was a git add dash capital A, and then git status. All on track, probably. Don't know if it's. Yeah. And then git add dash capital U is going to be add files that have changed but are already tracked by version control. That'll be another common one that we'll use. So now that these files are ready to be committed, we can go ahead and do our commit. So git commit dash M, which is the message that we want to put with this, the commit message. One of the most important things when you're working in an open source project with lots of other people, or even just yourself, is to have good commit messages, because you will thank yourself in 6 months or 8 months or a year down the road when you want to know exactly why you did that change. This, though, is just an initial code dump into the repository, so we're going to have a not very helpful message, which is initial commit. So we should see that 9 files have changed with 225 insertions. Now this has all happened locally on your machine. None of this is up on GitHub yet. So just put it onto GitHub. We need to use the command git push. After we do our push, I'm going to go back to my repository page on GitHub and refresh it. And now you see that there is our content there, our hugs directory, our setup.py, and we see that the latest commit was 42 seconds ago. So anybody have a problem getting pushed to GitHub? Yep, okay. If you're having a problem, put your red sticky up. Okay, so I think everybody is squared away now with Git. It can always be a little bit tricky, especially if you're not familiar with using Git from the command line or working with GitHub. So now we can actually get on to talking about testing. So testing is a very important thing for your open source project. It helps ensure that you're getting correct results, that changes to other libraries that you depend on aren't breaking you. It helps make sure that bugs don't come back. And there are a lot of different types of tests. I'll very briefly hit the high points of it, but the point here is not to talk about the semantics of testing so much as show you how to do it. And so we're going to use PyTest. It's one of the most common frameworks for doing testing in Python. And we'll actually write some tests for the Hugs library, and then we'll look at our test coverage, which is another important metric that you might want to look at for your project, is how many lines of your code are actually being hit by tests. There's a lot of nice tools that will help you look at that. And maybe you realize that a certain case or a certain path through your code isn't being tested, and you can then write that test up. There's a lot of different schools of thought when it comes to testing, but for our purposes, we'll just cover 3 types of tests. So unit testing, which is testing a single unit of code. So this is a function or a method, something very simple. Does it work in isolation? Then there's integration testing. So now we have multiple pieces of code that are working together to perform a certain task. Is that working? Are we getting the expected outputs from that? And then a really important one, which is regression testing. This is a user has reported a bug, or we found a bug, and we're going to write a test to make sure that that bug doesn't come back in some way. Another buzzword that you'll hear quite a bit is test-driven development. Does anybody here practice TDD? Couple? So the rough idea here is that you write the test before you write the code. So you know exactly what you want the output of this new function or this new method to be. So I'm going to write a test that will have the API that I want, and I know what output I want. Then I write the code to make the test pass. And it's always good. I like that methodology because you then know that your test and your function are both working. So ideally, you would need to install PyTest if you're doing this on your own from scratch with a command like conda install PyTest. We've already have PyTest installed after you made the environment, the setting up open source environment. So if I do a conda list, you can see all the things that are installed. And up here we have PyTest, as well as cov, flake, and a few things that we'll get to later on today. So what PyTest is going to do is crawl through our directory structure and look for files named test anything, so test*.py. And it's going to run all the functions in those files that are named test anything. So we can go ahead and look in the Hugs repository, open up your very favorite editor, doesn't matter what it is, VS Code, Atom, Vi, Emacs, whatever you choose. And if we look in the Hugs directory, we'll see that there are two more directories. See if we can make this a little bigger for you. Doesn't look like we can make the navigation bar any bigger, just the code. But if you look in Hugs, there are two directories, calc and plots. Now if we look in calc, for example, you'll see that there are two Python files, geology and met, two different types of calculations. And there's a test directory. In that test directory, we have test geology and test met. So when we run PyTest, it's going to start crawling through here, go to Hugs, go to calc, go to tests, and then find these two files. If you look at one, for example, test geology, this is a short one right now, we'll be adding to it. See that we have a function Snell angle in the geology submodule that we are going to be testing. So our function test something, so PyTest will see this function, it will run it. So Snell angle with these arguments is going to be called. And then we assert that the result is almost equal. This floating point comparison is hard, as you'll see. So we take our result and we say that it should be equal to 19.43022 to 4 decimal places. So if that function does not return that result, the test will fail. It's a nice, simple example of a unit test. So if you go back to your terminal, we're going to run the existing test. So there is a small test suite in Hugs right now. And to do that, you just have to type PyTest. So PyTest and press return. And you should see that there were 4 tests and that they all passed in just on the system a little over a quarter of a second. Did anybody get a test failure? Excellent, because you shouldn't have. So far, they should all pass. So we're going to do a little activity now. Oh, mm-hmm.
So the Snell angle function on my system is in calc geology. If you import from hugs.calc, imports Snell angle, how does that even work?
Okay. So in calc, there's a dunder_init file. And from there, we import star from geology and met. This is just a nice way to break up, for example, in metpy, which is the package that we both work on, we have hundreds of calculations, so we have them broken up into, say, kinematics and basics and dynamics and these kinds of files that make it easier instead of having one giant many thousand-line file with hundreds and hundreds of calculation functions. This is a nice way to structure your project. That's an excellent point. Any other questions so far? It's test and then anything.py.
Okay.
Right. And it looks for functions in those files that are test and then anything. And if we have time at the end of the day, we'll get into some advanced PyTest things, like doing image comparison tests and all that. If we don't have time to get there, there are some notes for this on the website as well, though. Okay, so now that everybody has their test suite and they've run it and it's passed, we're going to add a test. So if you look in the calc folder, close these out, in met, there is this function, line 65 of met.py, get wind components. So what this does is takes a wind speed and a wind direction and tells you what the U, or the east-west component, and the V, or the north-south component of the wind is. This is just breaking the wind vector down into its components. And we have a little warning in here that if the wind direction is greater than 360 degrees, we're going to warn you about that and say something might be wrong. Otherwise, this is a relatively simple and straightforward calculation. So what I want you to do is to write a test to verify that scalar values work with this. So pass in a scalar for speed and a scalar for direction. Make sure that works. And then write another test to see if it works on an array of values. So pass in an array of speeds and an array of directions. You should get an array of output. So go ahead and try to write those tests. They will be in test met right here. There's some patterns that you can look at there. When you get done, put your green sticky up. Go ahead and take it down if it's already up, though. And red stickies if you have a problem. Okay. So in the interest of time, we're going to go ahead and move forward here. So did anybody encounter any problems when they were doing this? Everybody should have encountered problems when you're doing this. This is the great thing about writing tests, is you catch weird things that happen in your code base, right? So the first test that we'll look at down here is this test when comp scalar. So I've got a little docstring here that tells me what the test does. That's always a nice thing. And I'm calling get when components with a speed of 8 and a direction of 150. And I use to assert almost equals to check that U and V are indeed correct, in this case out to 3 decimal places. Yes. Also, these solutions are on the website. If you click on lessons and testing, you can get this code as well. Any questions on how that test works? No? Okay. So then this test when comps basic, here we create an array of speeds, an array of directions, every 45 degrees in this case, from 0 to 360. And then we are passing those, let's see if I can find my cursor, there we go, to get when components. And we have arrays for the true U and the true V that we should be getting out. You could just put values in there. Here, since we know that 1 and 1, hypotenuse is square root 2, we simplify a little bit here. Now, if you try to run this with PyTest, you see that we get a failure. This is why we want to test with scalars and arrays, because users might pass either one to us. And in this case, it's not working. Does anybody know why? What? Right, so it's down here in this if window greater than 360, so that's ambiguous if I'm passing an array. So what we can do is wrap this in mp.ini. So now if any element of that array is greater than 360, we'll get the warning. If we run PyTest again, now we should have 6 tests that are all passing. So it's one of those things that you may not think about, but when you're writing a function, if you intend it to be able to accept scalars and arrays, you should test that it can indeed do both of those things.
Also, the note in the documentation for the function says
Right, so you could test passing a list or sets of tuples. Yeah. Yeah.
So then you have to wind up wrapping like into that array around anything.
Right.
These things got stolen out of NumPy, and I thought maybe Gristed or list the array list for that case. But it's, yeah, so I don't know if there's a hard and fast rule. I mean, like in the NumPy, probably yesterday, he said, array like and include lists in that definition because all the functions work on this. Right.
Right. And it just gets worse when you use things like unit libraries to add further testing. Yep. Okay, so there's a couple other common tests that we might want to do. One would be to test if a warning is raised, or you might want to test if an exception is raised. Somebody had asked me during the activity, how do I test and see, is a file not found error raised here? So the first thing that we'll do is write a little test to make sure that our warning that we just fixed here works. So if you want to follow along, open test.met. You bring the bottom of this up so you can see it in the back a little better. Can everybody in the back see this okay? Big enough? All right. So we're going to write a test that makes sure that the warning is raised when the wind direction is greater than 360. I'm going to define a new test. Test warning direction. Give myself a little note about what it does. So test that warning is raised when wind direction greater than 360. And so we're going to use a context manager here with PyTest dot warns. Then we can tell it the type of warning. In this case, if we look back in MET, this is just going to generate a user warning. When you do warnings.warn, that's the default. Yeah. And then we're going to call getWinComponents with speed. And ideally, we're going to put a direction greater than 360 in. First, I'm going to put a direction less than 360 in to make sure that my test is working. It's always a nice sanity check to make sure you understand how to use the test setup here. I'm going to go ahead and save that. And then go run my test suite. Come over here and run PyTest. What we need to do is add an import of PyTest up here at the top. Okay, so the test failed. It did not warn. That is what we wanted to see. So now we'll go back and make this something over 360, say 480. And run the test suite again. Now I have 7 tests that are all passing. So we now have successfully tested and proven to ourselves that we're successfully testing whether that warning test works or not. The other test that you might want to perform is test if an exception is raised. So that's very similar. Instead of PyTest.warns, it's PyTest.raises, and then the type of error, or the type of exception that you want to test for. So what I want you to do, and I will pull this up on the website, though try not to cheat and look at the answer. So here, activity. Add a test to ensure that a value error is raised on the Snell angle function when the top layer velocity is 0. So a 0 velocity makes no sense in this problem. So we want to make sure that we get a value error on that. So go ahead and take your stickies down if they're up. Green stickies up when you get this test working. Red stickies if you're having problems. Okay, so we're going to go ahead and put this test in. So I'm going to add a new test to not test met, but test geology. We're going to go ahead and import PyTest. And then add my new function here. So def test snell 0 velocity top. It's nice to be descriptive with your names since you're not going to have to type these. It definitely helps when you're looking for the tests later on. So test that error is raised with 0 velocity top layer. So again, using a context manager with pytest.raises. I told you that you're going to be looking for a value error. You can see that that's what's raised in the code. So value error. We're going to call the Snell angle function. And we'll give it a 0 value. So this is incident, I believe it's incident angle, top layer velocity, bottom layer velocity. So we want to give it 0 for the top layer. We'll save that and run PyTest. Now we have 8 passing tests. If you wanted to make sure you were using that right, you could give a non-zero velocity there. And we get a did not raise value error. Okay, so any questions on testing for warnings, exceptions, and so on? Okay, the last thing that I want to show you is how to check coverage on the command line. And then we're going to take a little break, and then we'll move on. So I'm going to use PyTest again. And this time I'm going to use flag COV equals hugs. So this says I want to look at the coverage of the hugs library. And this shows us how much coverage we have on each of the files in the library. So for example, right now, plots, special plot has 0% coverage, and we'll address that later on. So this is how much of that Python file is actually getting hit by your tests. Do you have lines that are not being hit? So for example, if I go into my met module and I add, you can see right now met is at 100% coverage right here. I add a function that does nothing. And then I run this coverage check again. See now that my coverage has dropped because I have a function that has untested lines of code. This is a good thing to keep an eye on as you add code. Make sure that, for example, a warning path is covered that you may not have thought to check on. Yeah, you can put out an HTML coverage report. As we'll also look at some of that this afternoon in terms of the automating this test. Oh, we're not going to. Later this morning, yeah. We're not going to keep you here all day. Okay, so if there are no other questions, take 10 minutes. So we'll come back at 9:50, go out, get some coffee, stretch your legs, get some fresh air.
All right, let's get this show moving on here. So tests are great. I love tests. They help, we just saw it, found bugs. We proved to ourselves that things are working correctly. What really brings out the power of tests is when it's run automatically all the time so that you know when things break. So how many of you have ever heard of a term called continuous integration? Okay, a lot of you. How many of you actually use continuous integration? Fewer. Okay. So if you're not familiar or you've heard the term but you're not really clear on what continuous integration is, what that term comes from is it means that changes to a code base are continuously integrated into the main part of the project. In terms of our open source projects here running on Git and GitHub, what it means is master is always kind of in this state where things are working. You don't have this half-broken thing because all your tests are passing. And this process called continuous integration is enabled by essentially running your tests every time you make a commit. and you have a system that runs the test for you so that you're not doing it manually, but you can ensure that things are staying broken, or if things break, you immediately get notified, and it's not, 6 months later when you're trying to get a release out the door that you finally are aware that things are broken. But instead, your tests are always being run. And so there are a wide array of tools and online services that support continuous integration. There's a tool called TravisCI that we'll be working with today, and that allows you to run your code, run your tests on Linux and Mac. There's a service called AppVeyor that runs tests on Windows, or now they have Linux support. There's also CircleCI that does Linux and Mac as well using Docker containers. And so all these nice online services exist to provide continuous integration services. And for open source projects, they generally give you free access. It's very nice to have. And so we'll run through setting up Travis now. One of the other things that makes these services so powerful is when you have pull requests. So you have an open source project, someone wants to contribute changes, and so they open up a pull request against your code. And without these services, you get the pull request and you're kind of staring at the code, trying to understand, does this look good? Is it going to break things? If you're really feeling energetic, maybe you check out the code and test it because you're trying to do your due diligence. The beauty of these services is that they will automatically run your tests on the pull request, give you status notifications within the pull request. These changes are good, these changes broke some things, and so it really helps give you peace of mind on pull requests. Are these changes good? I use it all the time, even if I'm not making pull requests to other people's projects. Our development workflow on MetPy and other things we work on is exclusively through pull requests because of this infrastructure that exists. So we open a pull request on our own code, all the tests run automatically on Windows, on Linux, runs a bunch of other checks, and so the code that we're committing on a regular basis we know has already been tested more fully than we probably do locally. And so that's kind of the power of using services like Travis. So let's start by getting Travis set up here. And so the first step here is you guys will need to create an account. We can go to TravisCI.com. Why am I still logged in? All right. This should be what it looks like for you out there, right? This is what you're seeing? So if you click the big green button here that says sign up with GitHub, you're going to get an authorization screen from GitHub. It's going to say Travis Pro wants to access your account. It needs your email address, access to your repositories, organizations, whatnot. So.
What is the request that you're doing? Which request on organization?
The request on organization just means you're requesting from whoever is managing the organization that Travis gets access to the repositories for that organization. Not necessary right now, since you only need to worry about your personal accounts for this purposes of this tutorial. So you should be able to just come down here and click the green button to authorize Travis Pro. Might need to log in again, or at least confirm your password. So I came up with this for me. I'm going to guess for most of you it came up with kind of a blank screen or asking you to choose some repositories. So let me get back over here. Here we go. Okay. So this is kind of what you guys are seeing, this screen. Sure. So if you go to TravisCI.com and go to sign up with GitHub, you get that one? What was it? Travis-CI.com. It's actually .com now. Was there a dash? That's strange. Basically, there's one difference. They're working on moving now from .org to everyone being on travis.com or travisci.com and changing some of the features. So I was trying to get everyone on the .com version. It should work either way. So I got here because I have some existing projects sitting here, but if I go over to my profile and I can manage repositories on GitHub. So is everyone else seeing this screen when they logged in? Yes, no, maybe. Seeing some yeses. Okay. I mean, this is going to be the tricky part of this right now, is getting this all set up. Well, you don't have to give it access to all your company's organizational accounts. If you should be able to just give it access to the really. I don't know any way around that, other than we're going to select only one repository for things to be running on right now. I don't know if that works for you. If not, then right. This is activated. Okay. Sorry, for purposes of the tutorial, I was not willing to nuke my entire Travis account. So you can get to access and get here where you're selecting GitHub repositories. What we want to do here is come down to repository access. I'm going to say only select repositories do I want this activated on. And I'm going to choose my new Hugs repo that we created, or whatever you called it. So he said click.
So there's a button when you sign up with the travel board. There'll be a button to activate. So with that, the last permission.
So we'll make sure everyone gets through this part. I knew this was going to be the most challenging step in this process, was getting the initial configuration of a web service that I've used before and you guys haven't. So the quick one I went to was TravisCI. I had to go to my profile. I know when you go through it the first time, it does pop up some things that should lead you here, but I'm managing my repositories on GitHub.
So I got that subscription line too, where that should be.
You're not paying them right now? And since all my only ones I care about are my public repos, it's not a big deal. So if we click Manage Repositories, it's going to bring up this screen right here. And it's saying it needs read access to your code, read access to some metadata and pull requests, and then it needs write access for checks and things. And so down here, you can say just run it on all my repositories. That's way too many. I just want certain ones to run on. So I'm going down here and saying only select repositories. And so I've selected, I don't even need that one anymore. And so I just have it doing Hugs Doppler shift. You should select the repository you created this morning that we've been working with so far today. Once you've done that, click the big green Save button. So now all the settings should be saved, and if we come back to the Travis page here, refresh, it should be there. If you've got it, please put up your green sticky. If you are having problems, put up your orange one and we will get you caught up, because I know this is the sticky part. All right, I don't see any orange stickies. Cool. All right. So now you have Travis installed in your repo. What are we going to do with it? So, the first thing I want to do is I'm going to come back over to my terminal here. What? Oh, I thought I heard something. If we run git status, we've been sitting here, we wrote a bunch of tests before. Let's go ahead and commit those changes. So git add dot, git status, git commit, add more tests, and then git push. All right, so we saved that work from before. So the first thing I want to do here is I want to go work on a branch so we can see how this pull request aspect works here. So create a new branch to work on. If you're working from the command line, then that's git checkout space -b. I want to create a new branch. I'm going to call my branch add Travis. You can call your branch whatever you like. So now I'm working on Travis. So to configure Travis, what we do is we create a plain text file in the repository called .travis.yml. So I'm going to come over here to Atom, and in the base of the repository, I want a new file. Actually, let me do this from the command line so you can see what I'm doing. Atom.travis.yml. So that's the name of the file. That name is important. If it's not named correctly, it won't find it, and you won't get any of the cool stuff. So now I have a blank file. Current working directory is there. Here, let's do that again. Okay. So, a new file. And so we're going to populate with a few things and have you guys typing this along so that you get used to typing these things up, and you will probably make typos and we'll get to work through debugging what's going on with these things. So, first line I'm going to write here is tell Travis what language we're using. This allows it to use some baked-in features, some defaults, things for different types of code. So it knows what types of things Python usually uses. It sets up a default Python install. We're going to say sudo false. Essentially has different infrastructure, and if you're doing sudo false, then it'll run on Docker containers and it starts up much more quickly than provisioning an entire virtual machine for you. I'm also going to say branches here. Say only master. What that's telling is I only want Travis to run on the master branch in the repository. Since we're making pull requests against our own repository, we have to be pushing branches up there to our own repository, and I don't want it running twice, once for the pull request and once for my branch. So it'll only run as far as branches are concerned on master. It'll also then run on pull requests. You don't have to have it set up like this. If you're part of a bigger project or something that you're collaborating with that has one main repo, then you could run on all the branches if you want to test different feature branches or whatnot. But either way, the pull requests will be getting tested. So we're going to start here for Python. I want to say I want to run on Python 3.6. Okay. So that's set up in the environment. And so I didn't explain this earlier. What happens here is every time these tests run, it starts a clean environment. So it goes through a whole set of steps in terms of setting up the machine, installing your software, installing the dependencies around your software, then running whatever script you want. So everything starts from a clean state. So it's also a nice check that you might work locally for you because of something about your environment that you might not have captured in terms of your install steps. Going through CI like this then goes through every step is explicitly listed here. And so it allows you to catch certain configuration type things or unstated dependencies and things like that. So how do we install our project? Okay. So we say pip install dot. So we were doing -e earlier for an editable install, so that allows it to point to your code so you can make changes and rerun and it finds it. We just need to install the thing here. We're not making changes to the code. Just do pip install. And then the last part we need is we need to tell it what we want it to do. So that goes under this script heading, and we just put a line here that says PyTest. So that's the entirety of our initial Travis configuration here. We tell it what Python version we want, we tell it how to install our package, and we tell it how to run the tests. In this case, no, we're not actually using that. Those should be set up, I believe, specified in the setup.py. So this isn't even using Conda right now. This is actually just using straight stock Python that Travis gives us. We could go through the steps, and if we have time, I'll show you. There are ways to tell it to install Conda as well and do things. That's not baked into Travis. That's just, essentially, you're writing a bash script here is what finally gets generated out of this configuration is a big bash script that it runs. And so you can put any step you want in here. But the basics here is just the Python version, pip install, and PyTest. In the root of the repository, so I have it in, I'm in Hugs Doppler shift here. If we do an ls-a, there's .travis.yml. So that's in the base, top level directory of the repository. So if you had your text editor in the Hugs directory, then you should go one level up. All right, so I've saved it. If I do git status, it's not tracked. So I'm going to do git add.travis git commit add Travis configuration. And then we need to push up our changes. Now, if you're following along, I had you make a separate branch for this. So if we need to push that branch up, git push, I'm going to say -u because I wanted to basically set things up so that it's tracking back and forth between what I push to GitHub and what's here, so that in the future I can just say git push, essentially, is what I want it to set right here. So that's what the U is going to do. I need to push to origin, because that's where I cloned from. And then I want to push my add Travis branch. If you're trying to follow along, that was the magic push command.
So the Vue itself recommends setup string. So what's the difference between Vue push setup string and Vue push transfer?
I don't know the first one you were talking about. I've not used that one. I may just have been using Git way too long. It might be the same. Oh, set upstream. U, I think, is short for set upstream. Okay, yes, then yes, they're exactly the same. So, for future note, then yeah, that's. Should already be up to date. Yep, okay. So, if I come over here to my GitHub repository, where is it? There it is. Okay, so I'm back here at my Hugs repository on GitHub. I'm going to refresh here. So we see it already says, okay, you pushed a branch here. If not, we could come down here and see the branches. Has everyone been able to push and they see this green button over here for create pull request? So I'm going to compare and pull request. I only have one commit, so I already pulled the name of the pull request from here. And I'm going to say create pull request. If everything works right, this is what you should see. You should get these yellow status indicators. What the yellow means is it hasn't completed yet, it's running. If I come over here to the details tab, we see a whole bunch of information here. This is in the checks tab on GitHub. I see I got a failure. That's pretty much par for the course. And I can come down here and say the build failed, so let's go see what's going on.
If we did not get Travis coming up at all,
Then put up your orange sticky and we'll run through it because I'm sure there's going to be a few. So actually, let's go ahead and get everyone there before I diagnose what's going on here and walk you through how to figure that out. Let's get everyone with Travis working. All right, so we got everyone squared away here for now. I mean, we managed to learn many ways of how to fix Travis configs. It's not failures. This is, believe it or not, this is a regular occurrence for me of like, okay, why isn't Travis working this time? It just can be a little picky, and it's not a computer you can just log into and do things with. So, you know, you have to, it's a lot of git commit and push and see what happens. So now we've got everyone. Let's go back here to my pull request, which is over here. So I'm over here on this, I'm going to go to the conversation tab on my pull request. And so we see, okay, the pull request, the build failed, and then it also gives me this one down here saying the build failed. So if I go to details, I get a log of what's going on here. Oops. All right. And so it gives you a nice log of what the machine was doing the whole time, so you can try and trace back, go through what was going on. And so I open up this pip install to see what happened there when it tried to install pip, or install hugs. And it's collecting matplotlib a whole bunch of dependencies there. Okay, so it installed hugs just fine. So now the next question is, why can't it find hugs.calc? And I don't understand why I can't find hugs.calc. You know why?
Yeah, it's not a setup. So hugs that count
Oh, okay. I think I know what you're saying. So I come over here to my editor and open setup.py. You mean here? Okay. So I've opened up setup.py. So this is again why testing is great and why these things are good. It works. Our hugs package works just fine with a pip install -e, but actually doing a regular install, it's not picking up everything. So we need to do hugs.calc and hugs.plots. Save that. Come back to my Git terminal here and say git add setup.py, git commit -m, fix buggy setup.py, and git push. Sure. So the changes are, where's my editor? There we go. So in setup.py, there's a line here that says packages. And we were only listing hugs before. We need to list all the sub-packages as well that we want it to install.
So why did that work on our
Because pip install -e is only setting up a symlink, more or less. And so what that does is basically points to our directory in a repository where it had hugs, and the rest of the Python import machinery took over and allowed it to find the directories. When we're doing just pip install, it's copying files, but because we didn't list hugs.calc and hugs.plots, it didn't copy those files when we did the install. So subtleties of Python packaging. I'm not sure if the tutorial this afternoon is going to cover things like this or not, but welcome to your exposure to details of Python packaging and fun. The quick workaround on testing to get through this on Travis, if you hadn't pointed out what the problem was, would have been just to do the pip install -e on Travis. But I like, when I do my Travis configs, I like to do things like the users would be doing in terms of how they install things so that you can catch things like this. I wish I could claim that this was a intentional teachable moment. You're kind. No need to look at the man behind the curtain. All right, so that's a change. So if I come back over here to my pull request here, let's see, this tab had it. So if I go back, so if I refresh this page, okay, we see the new commit showed up on the pull request. So if you hadn't used pull request before, one of the great things is you can just keep pushing commits to your branch, and it keeps updating the pull request. And in this case, notice we got a green check mark. I can expand this and say show all checks, but now Travis is happy. I can come down here again and go to details, and I can go back and look at the log and see, okay, this time PyTest ran, and we see the same screen we were seeing locally in terms of the PyTest output. So good, everything ran just fine on Travis. If you have it Travis green right now, please put up your blue stickies so we can get an idea. Orange stickies if you are not green yet. The next exercise, just so I get an idea so I can keep things moving along and you can get to play with it, is great. We have Travis running on one version of Python. Let's expand it and let's run on 3 versions of Python so we can catch any issues that come from running on Python 2.7, if we're still supporting that, or running on Python 3.5. If you're going to do that, all you need to do is modify what's under this Python line. And you can just add an additional line and say -27. So make that change, put 2.7 there, put 3.5 there, commit the change and push back up there and see if it runs on your multiple versions of Python. And then for those of you who are not there yet, we'll get you fixed up. All right, I think we have a couple builds in progress, but I think we're doing all right here. So I'm going to finish off mine here. I'm going to say add my Python 3.5 here. So here's my full configuration. Git status, git diff, okay. Git add.travis.yml, git commit, test on more Python versions, git push. Okay, so we'll come back over to my pull request tab. Gonna let that run. So now we see when you add those Python versions, you get 3 builds here, and it does them all in parallel. So we can see what's happening on Python 2.7. Okay, it's downloading all our packages. Oop. If you click the little button over here, it'll actually follow it for you. Although it's already done. So 2.7 succeeded. 3.5 still running. 3.6 is running and not doing anything. 3.5 is tired. Sadly, par for the course. Oftentimes it's just sitting here like wondering what's going on here, why is it going? But okay. Wow. So 3.2, sometimes it's just waiting for the output to come in. It's actually running, it's just the log hasn't shown up. I could. It's not hugely important. I mean, and you guys have all big green buttons, right? It's all showing green on your pull request. So I'm just going to ignore mine, the status of it, because it's fine. So mine doesn't look green. Yours should look green. And so you can just click the big button down here that says merge pull request and say confirm merge. So that's setting up Travis, and there's a lot more you can do. I mean, like I said before, what this configuration ends up being, if you come over to travis.yml, these install and script lines, Travis is essentially generating a bash script from this. So you can put bash syntax in here and do all sorts of shell scripting type things. You can have conditional jobs running in here. You can put things, environment variables, set up here and do things conditionally on environment variables. You can deploy, you can build things on Travis. You don't just have to do tests. You can build your docs. We'll talk about that in a little bit later, at least building them. You can deploy things to GitHub pages from here. You can build things and upload them to S3. You can do almost anything and just treat this as a, when I get a pull request, do these things. And so this is a real, this is the basics, and it took some finagling to get this set up, but I wanted to at least get everyone's hands-on with, this is how you set up Travis, here's your configuration file, here's how you fix when things go sideways. But it's really powerful, and already off the bat, we've got all our tests running on 3 versions of Python. With that, I want to get John moving on to Flake8 real quick. When was our last break? 9:50? Let's take a 5-minute break. Get up, stretch your legs, clear your head. I've seen a lot of places, yeah, using that. Pulling in, yeah, yep. Because using this, you can make sure your tests pass and that everything's green. And so it should be a safe deployment. Emphasis on should. But that encourages you to make better tests then, because it's really nice to have everything automatically happen. Yeah.
Okay, so we're going to go ahead and get rolling again. We've got quite a bit to do, so we'll take a quick look next at doing things with Flake. Okay, so one thing that we want to make sure if we've got a library that's got a lot of contributors, as many open source projects do, is we want to make sure that the code style is something that's maintainable and clean. We've got minimal variations in the style. And one way to do this is to use Flake 8 to automatically run these checks. There are a bunch of different plugins for Flake 8. On the website, I have some of them listed. There's also a bunch of them in your environment.yaml file that we installed from this morning. Things like we can automatically check for copyright notices at the top of every file. We can make sure that everything has a docstring, that you didn't forget to write it. We can check that import orders are proper. You can check for so-called bad quotes, the double quotes, and make sure that you don't have those. Or you can look for print statements, because you probably don't want to have print statements in your library code that you're shipping. So there's lots of different plugins that you can do. First, we're just going to run Flake locally and look at the output and see what kind of shape the Hugs library is in. So we're going to do this. We're going to type PyTest again on your terminal. Space, dash, dash, Flake 8. This is because in that environment file, PyTest-Flake 8 was installed. So this is already enabled for you. If you go ahead and run that, it runs our tests, and we see that we have some Flake failures in here. So scroll up here. We have a line too long. So 79 characters is the default line length. It wants your lines to be shorter than. Missing new line between some imports. Here we expected 2 blank lines, found 1. There's a lot of things in here that are all very minor and aren't keeping our code from running, but they are keeping the style from being consistent. So running this locally is always nice. Before you go ahead and push, that way if you add this to your Travis build, it doesn't. You don't have to wait on that to fail. You can see it locally. We're going to do a little bit of warning suppression though. For example, the max line length restriction of 79 characters is in our... Is it similar to Pylint? Yeah. Yeah, so we're checking the same basic types of things. I think the line length of 79 characters is a little bit restrictive. So we're going to go ahead and bump that up to 95, and we're going to ignore this 403. It doesn't like our star import that we're using in our dunder inits, so we're going to ignore that as well. So if you go ahead and open up your editor, in the top level of the repository, the same place we put our Travis file, we're going to create another new file. And this one is going to be called setup.cfg. And this is just a configuration file, so sort of the ini file format. So we're going to first say we have a Flake 8 thing that we want to configure. And we want to change the max line length. And I'm going to set that to 95 characters. So that will just capture that line that we've got. I also want to ignore F403. So go ahead and save that file. Then we're going to go back to our terminal. I'm going to clear this output, and we'll run that same command again. So PyTest --flake 8. So we still have failures, but if I scroll up, my line length failure that was up here is gone because we're at the maximum, and I don't see any of those F403 star import errors. So did anybody have a problem getting that to work for them on their system? No? Okay, we got one. Anybody else having issues? Green stickies up if you're good, red stickies if you're having problems. Okay, so we can go through and we're going to fix a couple other of these errors real quick to give you an idea of what some of the common ones are that you might see. Then we'll add this to our Travis build, which since we don't have all of them fixed, the Travis build should be failing. If it's not failing, then we know that we're not doing that check properly. And then we'll move on to talk about documentation. It's the last thing for this morning. So you can go back and scroll through all of those errors that we got. And most of them are relatively self-explanatory. We're going to start out by looking in calc met.py. Make our text a little bit smaller there. So we have a missing new line in between imports here. Warnings is built-in, numpy is external. So it wants a new line there. So you can go ahead and insert that. And we will save that. In the test for the met functions, so test underscore met.py, we have a complaint in there about a white space issue. So if we go back and find our test met here, so test geology. Okay, so missing white space after comma. So that's in line 11 and 12. We'll go back and look for that. Ah, there we go. So here we're missing a white space after these commas. So we add a white space there. Add a white space there. See, this is a very finicky check, but it's nice for making sure all of your code looks the same. So go ahead and save that. And then one thing that it is complaining about that we're not going to do for the sake of time, so we can try to get through as much of the material, is we can go back in the special plot.py. We are missing a docstring in a public function. This is telling you you have a function. We can go look at it over here in plots, special plot.py. We have this function random plot, and there is no docstring, which is not something you want to ship. So we could go through and add a docstring to that, and that would get that particular warning to go away. Any questions on any of those that you're seeing or anything that's unclear about how Flake works?
So I'm seeing one that says, so that I got an error about an unused variable in the way that I wrote my test. So I replaced it with an underscore. My understanding was like that is a safe sort of throwaway thing to put in there, but it's saying local variable underscore is assigned to the never used. So I thought was the whole point of the underscore.
Is it only a single return value?
Yeah.
Then you don't use it at all, right? Yeah, I know what you mean. But I think it's because you don't have to use it, whereas there are some cases where you don't underscore for if you're returning multiple values and you only want one of them.
And there are definitely cases where your project can be passing the build, and then Flake updates, and there's a new rule. We see this all the time. And then your cron job goes through, and all of a sudden you have a lot of failures because of a new rule. Okay. So now we're going to add this to our Travis file here. And we're going to run the Flake checks on Travis. So go ahead and open up your .travis.yaml. And we need to add some things here. So first of all, on PyTest, it's going to be just like we did locally. PyTest -- flake 8. That alone will not work because remember, every time Travis starts up, we have a new machine with nothing. So it does not have any of these flake checkers. So we need to add to our pip install here. So we're going to add PyTest -- flake 8. I'm going to add a couple of the optional packages, flake 8, docstrings, and flake 8 import order. So once you do that, go ahead and commit that. You can, I would recommend making a branch. So just like Brian did before, get checkout -b, make a branch, commit this, push, create a pull request. Go through that whole cycle so you can get yourself a little bit more used to it.
If you haven't done anything Git-wise since we last did it before, we can just read the same range that process the launch.
Yeah. So put your green stickies up when you get this running on Travis, red stickies if you're having a problem. I'll put this back up in just a moment. I'm going to go ahead and commit.
Okay. I'm assuming everyone's seeing an error message when they run on Travis right now. Because, yeah, packaging is fun. I'm going to take a crack at this, but...
Just you add flake 8 to the Travis YAML, right? So the PyTest flake 8 stuff, not flake 8 itself on the
I don't understand why pip installing there isn't picking up flake 8 on its own, but that makes sense. Again, packaging. There's a tutorial on it this afternoon.
At least I made that change and it worked.
Okay, good. Okay, so to put this back up, the change you need to make is it wasn't just enough to have PyTest flake 8 docstrings, and flake 8 import order. We also need to have flake 8 explicitly installed for reasons. Well, since it's about a utility that we use when we are checking it, it's not an install requirement to run Hugs. It's just, so you could make an extras install on your setup.py and list it like for dev or something. I've done it on a few tools.
Or run the create environment.
You're right. So part of the, except we haven't installed Conda yet here. So this is all running off of Travis's Python installs, which is just stock. You can install mini Conda in Travis. There are recipes out there. I use it on a few things, like when we do continuous integration tests of our workshop materials, and so we're running these Jupyter notebooks every time we change them, and there I install mini Conda and set up an environment and stuff. It's also nice for some of our projects to also test how pip install works, because Conda and pip are different packaging, and sometimes things work on one and not the other.
You guys make advanced time packages?
Yes, we do packages for both and test both. Excuse me, at least test the install of both. All right. Let's see, more blue stickies. So while everyone's finishing up, if you wanted to see the coverage numbers with Travis, you could just add to your script down here, like we did earlier. You'd also then need to add that to your install line. But yes, we absolutely do that on a regular basis. Well, you still need this. You still need to run your test with coverage. But then, yeah, but then an additional thing, which we won't get to, but I'll preempt at least talking about it later while we're finishing up here. You can use a service called codecov.io. Another one of these web services you can set up for a repository. And so you can add, this is where Travis has all sorts of stuff, and I encourage you to look at the docs, but you can say after script, so when I'm done testing, I forget what the command looks like, but essentially it's something like, I'm making up something here, but they have a utility, you'd pip install, and it uploads your coverage file to their service. And so you can also do, have Travis power automatic test coverage reports. And so the test Travis YAML for MetPy at this point, I think is, if not just 100 lines, it might be 150 lines of things, because there's all sorts of build variations. We have like 13 different jobs that kick off on Travis when the pull request comes in.
Also doing things like deployment.
Yeah, so when I have it set up so that when if I tag a MetPy release, not only does it run the tests, but it automatically generates wheels and uploads them to PyPI. So we could spend a day just doing Travis things. So I just want you guys to have an idea of, these are where you can expand. These are the kind of things you can do with Travis. And I encourage you to, if you're interested, go dig into the docs. And another good thing is to go look at open source packages you like and go see if they're using Travis and look at their configs and borrow their configuration. Because that's kind of how a lot of us do these things, is just, oh, that's a really good idea, I should be doing that, and expand that way. You good? So everyone happy with their Travis, Flake 8, ready to move on? We're coming up to lunch here, so we're going to finish up here with Sphinx and documentation. So how many of you have ever used Sphinx? I'm so sorry. So Sphinx is a documentation tool for Python. I guess it can technically work for other languages, but it's really used in Python. As opposed to using things like Markdown, which GitHub natively supports and does nice things with, Sphinx has a few things that help it make it the documentation tool, it seems, of choice for the community versus Markdown. One of those being that Markdown doesn't really know about multiple documents. I mean, you can put links between them, do full URLs, but you can't really just say, here's another regular Markdown file. When you're generating docs, link to this file, find where it is. The other thing that generally just doing Markdown docs doesn't do is it doesn't do anything for API documentation, for taking these docstrings you write with Python functions and turning those into web documentation. That's one of the things Sphinx excels at, is you can point it at parts of your code and say, I already wrote these nice docstrings for Jupyter Notebook type things. Please pull them out and include those in my web documentation. And so that's probably the big killer feature of Sphinx, and why people don't, in the Python community, don't just generally rely on Markdown to do documentation. And so we'll run through here setting up Sphinx real quick, and then I'll be, at that point, happy to take any other questions before we let you out for lunch. So, setting up Sphinx. So I'm over here at my terminal, and I am in the base of the repository. So I'm going to create a docs directory. So make dir docs. And I'm going to change into that documentation directory. And Sphinx comes with a tool that helps you get started. It's called Sphinx Quick Start. And so we can run that here. So sphinx-quick start. And so we'll run through various settings here. Do you want separate source and build directories? Sure. Name, prefix, or templates and static? Yeah, that's fine. Project name. Our project name, Hugs, or whatever you really want to call it. Author name. Sure. Project release. We'll call this the 0.01 release. It's in English. What suffixes do you want for files here? So we're just going to use .rst. So that stands for restructured text. So that is the format of, that's the markup language you use when you're trying to write things for Sphinx. It's kind of like Markdown with its own variations. Just another one of these. You can write text with a few other special things. Name your master document. Yeah, index is fine. Do you want to use the EPUB builder, so it can generate not just HTML, but it'll do PDFs or EPUBs or Mobi. We don't really need the EPUBs right now, so I'm just going to leave that as no. Autodoc, automatically insert docstrings from modules. Yes. Doc test, no. Sphinx. Sphinx, so that lets you link to other projects' documentation files. They have it up there. They publish this kind of manifest of their functions. So for instance, if I have code that relies on, does some NumPy things, I can mention the NumPy classes in there and it will generate the links to the NumPy documentation for that. So that's a nice thing to have turned on. To do entries, I don't care. Coverage, no, we're not going to worry about that right now. Image math, no. MathJax, yes, no, depending if you're going to put nice equations in there, it can automatically include MathJax so that you can write LaTeX style equations in your documentation and have them rendered on the web. If config, no. View code, sure. So that includes links to to the code for certain objects. GitHub pages, I'm not going to worry about that right now, but apparently this is a new one that it'll automatically set things up or do some things to make it easier to push things to GitHub pages, but we're not dealing with that today. Create a makefile, yes. Create a Windows command file, yes. All right. So that's quick start. Just asks you a whole bunch of questions and sets things up. So if I do an ls now, we see it generated some things for me. I've got a makefile here. I've got a make.bat. If I look in source, I've got some directories, including a conf.py and an index.rst. So, if we look at the index.rst, that's kind of what it looks like, the default. So it generates this basic, puts a comment up here, says, welcome to Hugs documentation, and then everything else. If you want to see what the conf.py looks like, so this is it generated this configuration file for us. And so it's just it's a regular Python file. It sets some variables, project, copyright, author, load some extensions. So here's where it put things like, we said yes, do autodoc, yes, Sphinx, and so it puts those in there. So it generated that for us, and we'll go back and we'll edit that to include some things as we go on. But it did those right out of the box. So right away, we should be able to build our documentation. How do you do that with Sphinx? Well, we have this makefile, so from the docs directory, or where we ran quick start, we could say make HTML. You hit enter. It does its thing and it generates some HTML files for your project. At least on my Mac, I can say open build /html /index.html. And voila, we have just beautiful HTML documentation for Hugs. So the last command I ran was I just said open. At least on the Mac, that opens it up in my web browser. So you can, if you use your file browser here, you can, from the repository, go into docs and go to build and HTML. And there are all the generated files, and then there's an index.html file here. So that's the process of quick setting it up, and that's how you build the docs. Nope, because we haven't told it to find anything, it hasn't done anything, it just gave us the bare bones skeleton that you can do a make HTML and it doesn't break. So, if I come back to my Atom editor, I can go into my docs directory or use your editor of choice. But if you open docs source index.rst, you can see this text file here, and we can start adding things. So maybe, clean some things up. I don't need that comment up here that this was quick start generated, so I'm going to delete that. I don't need to say welcome to Hugs documentation. I just want to say Hugs. So I can take that out and shorten that. And then I can start writing some actual text here and content. So I could say, Hugs, the hugely useful geoscience stuff, is a library of calculations. I can't spell calculations. For geophysics and meteorology. Okay, put that there. Index.rst. It is under docs/source. And then maybe, for instance, I want to, in here, add a section about our license that we chose. And say, so notice here, and this is an important part of RST, so we're under Hugs here, we put equal signs underneath it, so that defines Hugs as a top level heading. Down here I'm putting license and I'm using single dashes, so that's kind of a lower level of heading here that we're putting license under. And we'll say, Hugs is released under the terms of the BSD 3 clause license. All right. So that's the edits I've made. If I go back over to my terminal, I can say make HTML again. Go through it and come back over here to my web browser and refresh, and now we see much more beautiful content. So that's just editing this one file. Now, often you're going to have lots of other files. So what I want you to do is create a new file called, let's say, contributing.rst. Put it in the same directory as index.rst and put some content in it. And then we'll add it to our docs and have it show up there by adding it under this part that says talk tree. That's table of contents tree. So that's where you can put links to other documentation files in here. So under here, we'll just put just a name, contributing. No.rst here, just contributing. And then if you make the file contributing.rst and put stuff in it, when you build the docs, it'll link it. No colon or anything. And actually, there does need to be, I think, a blank line between the two. So take a few minutes and put some stuff in a file called contributing.rst, and then we'll build the docs and see it show up. The what? 3 spaces. Like lots of things use. And seriously, keep it to 3 because it does look for it. Again, part of the whole purpose of this workshop is to run through the errors that you run into and figure out how to fix them. So the one thing you're going to have in this contributing file
is you have to have a title, which is done by doing, and then you do the, like that, I believe. What else? You also, I think, have to have, let's see, I'm going to try this out. And there'd be a whole lot more content here, but I'm not doing that right now. So docs, source, contributing.rst, make HTML. Okay, so yeah, you just have to have an actual title block up here, text up here, equal signs underneath it. And if we come back to our HTML page and refresh, now we see our table of contents, and we get a link to our contributors guide. All right, the last thing I want to get to right here on Sphinx is I did mention it will pull your docstrings for you, which is the most important. This is the reason to use Sphinx and not Markdown, really. So we're going to need one more file we're going to add. So I'm going to come over here to my index.rst and add API. We're going to create a new file called API for the API documentation, the application programming interface, if you're curious. Okay, so there's that. I'm going to add a new file, the Hugs API is what I'm going to call it. You can title it whatever you want. So give it a title again. And here's the magic incantation here. Dot dot space. Auto function. 2 colons, because 1 is just silly. I kid you not, if you try to put 1, you will sit there wondering forever why it doesn't work. 2 colons. And then we give it a function name. So I say hugs.calc.getWindSpeed. So that's what we write there. So that's your magic incantation. And I'll leave it up there, but you're going to want to save that to api.rst in the source directory again. What's the warning? So when you went through Quick Start, did you say yes to AutoDoc or no? Okay, I'll show you where to look for that and we can solve that. So API to RST, save it. So in under the source directory, there's conf.py. So in there, this is that Python file that configures everything. If you come down to extensions, the extension you need is this one, the sphinx.ext.autodoc.
Is there some way to get something that will build your API.rst file automatically?
It's called auto summary. It's finicky. I started trying to set it up for this, and it just was going to become horribly painful. Also, on MetPy, we're actually moving away from it. Once you get to a certain amount of calculations, you actually don't want one gigantic table of calculations. So it's nice to try and group them, put them in tables, logically arrange things.
So you're saying you want to manually sort of organize that?
Yeah, I mean, there's a downside in that you've got to remember to add them. I like automation and I like auto summary that it can pull all the things, but it is a rickety part of Sphinx.
Because we already have code that's organized into packages,
Sure.
modules,
Yep.
classes, and stuff.
Mhm. Well, you can do that, but like we have MetPy.calc, And there are submodules in there, but we expose at the API level just metpy.calc and all the things. And when you have 150 of those, it becomes tedious for people to scroll through. So, but yeah, what you're looking for is auto summary. It has an extension, and there's an option. There's a script that has to be run to generate things, and then it just becomes a pain. And I'm happy to talk more about it, but it's honestly, without copying over metpy's configuration, I could not get it to work for this tutorial. If that tells you anything about how much more complicated. Like I could get a table, but I wouldn't get links you could click on. So, whereas Autodoc, it just worked. So there's that. There's my API to RST that has that in there, and index has API mentioned. So I should be able to come over here and do make HTML. I get some warnings, unexpected section title. That's fine. We'll ignore that for now. You just come over here to the browser. Refresh, there's our link to the Hugs API. And there you get, here's get width speed. Pulls the documentation string out of the code for us. And even gives me a link to the source code. So that's nice. The one thing is it's not really well formatted in terms of how it understands the docstring. It gave us stuff. So what we used for the docstring that we wrote for this Hugs project, it was a format called numpy.doc. It's the documentation standard that numpy uses. And so we want to tell Sphinx to understand that. So if I come back over here to my conf.py, we just need to turn on one more extension. It's called Napoleon. So I add a new line here after view code. Put in quotes sphinx.ext.napoleon. Napoleon. Leon. Save that. If I do make HTML again, yeah, I absolutely can. Let me just make sure that actually worked first. Yeah, okay. So I'll put that back up. There you go.
So is Napoleon specific to the sort of numpy format, or is it?
I think it might understand multiple formats, but it's certainly the easiest way to enable Sphinx to parse and understand the NumPy format of docs.
What about, so I think we use the Google Docs format?
Sphinx might use that automatically? I'm not sure. There's a different way of writing the documentation where all the types are listed a little weird and stuff, and that's how Sphinx does it by default. It's much more verbose that way. I think the default would understand that one, I think. So to show you the difference made, now if you look here, it lists the parameters, it lists the returns, the return type, and it also gives you a see also here. And if we had listed get win components in our API docs, so another auto function line, this link would actually, to see also, would actually be clickable. So you could, produce this nicely navigable API documentation for your project. So that's a real brisk introduction to Sphinx, as everything else.
So you said there's a way for Travis to run Sphinx and
Sure.
ReadTheDocs.
So just like we did, I won't show you how to upload yet because that's a more involved step. There's a tool called Doctor if you're wanting to push it to doctr. That's not for read the docs. That's for that was GitHub pages. For read the docs, that's a separate service that you can look at. readthedocs.org. You can create an account and point it at the repo, and it will just build Sphinx docs. Like you tell it where the conf.py is, and it just makes them and loads them. It's pretty.
So what's the thing that does the
Doctor, doctr. I think doctr, it might have just started or just came out. We don't use it either. We have our own custom keys and whatnot, pushing to GitHub pages. It's a complicated process. As far as just testing your documentation build, which is really good to have, to make sure it passes, that's as easy as, I mean, depending how you feel about Travis.yaml, going to Travis.yml after your test, cd into docs, make HTML. And now your docs are building on Travis, and so you can make sure they still pass the documentation build. Any other questions before you guys run out of here? For Sphinx stuff, anything that needs to go on the git ignore. Let's look. Git status. Okay. If I git add docs, I bet there's a lot of stuff that comes in. No, actually, apparently the git ignore that Git gives us is already ignoring the build directory under docs. But essentially, yeah, you just want to ignore the entire build directory. Any other questions? What was that? Oh, Napoleon. The purpose of Napoleon is to understand numpy formatted docstrings. So there's different formats, different standards for how documentation strings are listed. So if we look at met.py, we see this is what the docstring looks like, where it has its parameters, and this is how the name of the parameter and the type and the description and the return section to see also. Napoleon knows to look for these certain sections and then formats them nicely so that if we look at our web documentation, we get the bulleted list and we see the see also section, the return type. So Napoleon is what parsed that apart and generated slightly nicer HTML.
We have one favor to ask you. If you would take your stickies, if you wrote on them, that's okay, we have more. On the green sticky, write something that was useful today or something that you liked. On the other sticky, the red sticky, write something that you think we could be doing better and be brutal. We can take it. Other than that, just drop those off on your way out.
Yep, you guys have been great. Thanks for coming. And if you want to, we'll be around all week. If you want to talk more about setting up various things like this, happy to help share the knowledge.